Good morning, everyone. I am Sunil Vishwakarma, working as an assistant professor in the Department of Computer Science, School of Engineering, BD University, Lucknow. Today, in this lecture, I am going to discuss about the introduction to the computer network and how computer network is used, what are the applications, and many more things. So first of all, what is computer network? Network is an interconnected set of autonomous computers, or we can say that computer network is the uh, collection of computers, collection of devices, and those devices are interconnected through some communication medium. And that communication medium may be any wire or that may be wireless. And the devices will be autonomous. Means computers can function independent of others, and these computers or these nodes can exchange information with each other through the communication network system. Here in this diagram, this is the network diagram, and in this diagram there are so many devices: computers, network connecting devices, servers, and there are some devices which are connected through wire and some devices are connected through wireless medium or in open space. So this is the diagram of computer network. Next, what are the objectives of computer network? Why computer network is used? So main objective of computer network is resource sharing. Resource sharing. A resource can be any software, any data, any program, or any hardware, and that resource can be shared. The second objective is to provide the high reliability. It is achieved by replicating the files on two or more machines. So in case of unavailability or due to failure of hardware, those copies can be used. And third objective is computer organization has helped organization in saving money. So using computer network, money can also be saved. The fourth advantage is load balancing. If there is a problem and that problem is divided into sub problems, and those sub problems parallelly can be solved using different machines, and after that can be combined and we can find the solution of original problem. Next objective is computer network is a powerful communication medium. It can be used as a communication tool. We can see this objective in sending emails. The next objective is only authorized user can access resource in a computer network. There is username, password, and using that credentials, only authorized user can access the resource. So these are the objectives of the computer network. Next, this is the applications of computer network. In which areas computer network can be used? The first area is marketing and sales. How computer network can be used in marketing and sales? When we go any shopping mall for buying anything else, any product, sometimes we are asked to fill some feedback form, and using that feedback form, that organization analyzes that which type of products are in demand, and those organizations are located at different places. So with the help of networking, that result can be combined and organizations can use that result for identifying the analysis. Next is financial services. In financial services, in banking, computer network can be used. In manufacturing sector, electronic messaging such as email, directory services, in client server architectures. Next is information service. For information sharing, computer network can be used. Electronic data and exchange, in EDIs, computer network can be used. In teleconferencing, in cellular telephone, in cable TV networks. There are many more fields. In research fields also computer network can be used. So after this we can say that computer network is used everywhere in our daily life, in the field of engineering, in the field of geography, in every field of our life. Next, what is network architecture? Network architecture describes the allocation of tasks between computers in a network. There are so many computers in a network. So how tasks are distributed, how tasks are allocated among those computers. So there are two most common types of network architectures: peer-to-peer and client-server architecture. So we see one by one. First is peer-to-peer. Each computer on a peer-to-peer network becomes a file server as well as a client. Any computer can act in both the ways, as a server or as a client, whatever the requirement is. In peer-to-peer relationship, here we can see 4 computers, and these computers, every computer is connected to every other computer. So the main point of peer-to-peer network is every device is connected to every other device directly, and if at a time any two devices want to communicate, they enjoy the full bandwidth of those wires from which they are connected. The next architecture is client-server architecture. In client-server architecture, there is a server. In this diagram, there is a server and there are 4 clients. Server provides the services and client uses the services. For example, if any student wants to see his or her result, in his or her mobile, he enters his roll number and press enter, and within some time he gets his result from the server. So this request and response, for this request and response, HTTP protocol, hypertext transfer protocol, is responsible, and this request is known as HTTP request, and the corresponding response is known as HTTP response. So this is client server architecture. And after this, topology. What is topology? Network topology is the arrangement of the various elements. Various elements means in the network there are so many nodes. Nodes mean computers, network connecting devices, and the lines which are connecting those devices. And we can say those communication channels, those links. The arrangement of these devices is known as network topology. How these devices are arranged in the computer network. Essentially, it is the topological structure of a network and may be depicted physically or logically. So, topology can be classified into different categories: mesh topology, star topology, tree topology, bus and ring topology. We'll see one by one. This is the mesh topology. If in any network devices are connected using mesh topology, so this type of arrangement should be made. In this diagram, there are 5 computers and each computer is connected to every other computer in the network. So this type of topology is very costly, because if there are n devices in the network, every device requires n-1 input-output ports. So many cabling is required, but one biggest advantage of mesh topology is the privacy. No third party is sharing the communication channel. If one device is want to communicate to device 2, there is a dedicated link between 2 devices and no third device is sharing that channel. So this is very good topology for the purpose of privacy of data. Okay. The next topology is star topology. In a star topology, there is a central controller known as hub, and in a star topology there is primary secondary relationship between the devices. Hub is primary and all these 4 computers which is shown in this diagram will act as secondary devices. If any device A wants to communicate with the device B, that data goes through this hub. Means every data which we want to share from one computer to another will go through this hub. Problem with this star topology is, if hub fails, whole network goes down. Network will goes down. No device will work and there will be no communication between the devices. So this is star topology. Next is tree topology. In tree topology, in this diagram, systems are shown in the form of tree, and the real life example of tree topology is cable TV network. There is a hub, and if there is a requirement of new connections for the cable TV, that hub is connected to more hubs and more homes are benefited. Here this large hub, one large hub is shown in figure and 3 small hubs are shown. Here the large hub which is shown is primary and the secondary hubs are these 3 other yellow hubs, and after there are many computers are connected. So this is tree topology, and cable TV network is the example of tree topology. Next is bus topology. In bus topology, there is a long cable act as a backbone of the network. This long cable is shown in the red color, and this cable end is known as cable end. In this diagram there are 4 computers and 4 computers are connected to that long cable. The point where that computer and long cable connects, that is known as tap. The line which connects from the computer to the long cable is known as drop line. So there are so many chances for the collision of the data during data transmission in the bus topology. In the next lectures we will see how we can detect the collision and how there is the possibility of collision in the bus topology. We can avoid, we can also avoid the collision, and we can detect the collisions also. This is the bus topology. Next topology is ring topology. In ring topology, the devices, every device is connected to two devices. Means every device has two input output ports for connecting its two neighbors. In this way, all the devices are connected to each other. And one logical ring, it is not necessary that your network should be in the form of ring. Logically it can be in the form of ring. How the data is transferred in this network? If any computer wishes for the communication, that device holds the token. Token is an electronic signal, and in that token it appends the data. There is the address of sender and receiver, and that token is sent to along the ring, and that token circulates around the ring. If any computer wants to access the data, first that computer captures the token, matches the destination address. If destination address is matched with that computer's address, then that data is copied. Otherwise that token is free for circulating throughout the ring. So this is the ring topology. If there is any break in any cable, then there is no ring logically, so network will goes down. So this is the ring topology. And next is hybrid topology. Hybrid topology is the combination of all other topologies such as bus topology, star topology, ring topology. In a network, all the topologies are used. So this topology is known as hybrid topology. So this is the topology. Every topology has its advantage and disadvantage with respect to other topologies. Next topic is ISO OSI model. ISO means International Standard Organization, and OSI means Open System Interconnection Model. Why this is known as OSI model? Why this is known as Open System Interconnection Model? Because using this model, any two devices on the internet can communicate without bothering about its underlying hardware, architecture or software requirement. If there are two systems, one is physically located in Lucknow and another is physically located in Bangalore. In one system there is i3 processor, and in other system which is in Bangalore is Pentium processor. In one system which is in Lucknow there is Windows XP, and the other system which is in Bangalore is having Windows 10 operating system. But there is no problem. Both devices, they do not match with their hardware architectures and they do not match with their software's operating system requirements. In spite of that, both the devices, if they are in the network, they can communicate using this OSI model. So we will discuss how this model is used, and there are 7 layers in this model, and using these 7 layers, data is communicated from one device to other device in any network. There are 7 layers. You can see from the bottom to top. First layer is layer 1, which is in yellow color, physical layer. Layer 2 is data link layer. Layer 3 is network, transport layer, session layer, presentation layer, and application layer. So physical layer, data link layer, network layer, transport layer, session, presentation, and application. So there are 2 hosts in the diagram, host A and host B. Both are communicating, but user interacts with the layer 7. From which layer user interacts? With the application layer user interacts. If computer A wants to send some message to computer B, that message will be handed over to the layer 7 application layer, and after receiving that message, application layer sends that message to the presentation layer, then that is transferred to the session layer, transport layer, network layer, in this way physical layer. And after physical layer, this is the responsibility of physical layer, how that message should be transferred through the communication medium. And communication medium could be any wired medium or any wireless medium. So the responsibility of physical layer. When message passes from application layer to the physical layer, the output of physical layer is binary data, 0-1 data. The data is in the form of digital stream. But if that data is to be transferred to the communication channel, that must be converted in the form of electromagnetic signals. So physical layer decides how 0 is converted to the signal and how 1 is converted to the signal. How many volts are required to represent 0 and how many volts are required to represent 1. So each and every layer has its own function, and these functionalities are applied to the data, to each and every layer. The responsibility of physical layer is what will be the data rate for transferring, how the data will be represented, means what will be the syntax, which type of topology will be used, what will be the volt for the 0 and 1, what will be the line configuration, what will be the communication medium, whether it will be wired or wireless, what will be the communication mode. These are the functionalities of the physical layer. Second layer is data link layer. Data link layer deals with the physical addressing or MAC address. The functions of data link layer is framing, error control. These are the main functions of the data link layer. Flow control and access control. These are the functions of the data link layer. Next is network layer. In every network almost we talk about the IP addresses. So for IP addresses is also known as logical address, and these network layer deals with these addresses. So responsibilities of network layers is routing, and logical addressing. Fourth layer is transport layer. The function of transport layer is the process to process communication between the devices. So for the process to process communication, transport layer uses the port addresses, and port address is the 16-bit address. In next lectures we will see in detail these layers. Next layer is session layer. Session layer is used for the dial-up control, for the segmentation and reassembly. Next layer is presentation layer. Presentation layer is responsible for the translation of data, for the encryption of data, and for the compression of data. And the next layer is application layer. All the protocols such as hypertext transfer protocol, file transfer protocol, telenetworking, and email SMTP. So these protocol works on this layer, application layer. So for the host A, data is hand over to the application layer, and finally it comes to the physical layer, and after that physical layer transfers to the communication channel, and it is received at the physical layer of the host B, and the reverse process is done, and at the host B side, after the application layer, the original message is received. So in this OSI model, there are 7 layers. First 3 layers are network support layers, and the upper 3 layers, 5th, 6th, 7th, are user support layers. And transport layer acts as a bridge between network support layers and user support layers. The first 3 layers of the OSI model, that is physical, data link, and network, are responsible for the physical movement of data. Physical movement of data in the network from one point to the another. For moving the data from one place to another place in the any network, only these 3 layers are responsible. And after that, upper 4 layers, that are combination of, not the combination of hardware and software, they are part of the softwares. They are implemented purely in the softwares, but physical layer is purely hardware. Data link and network layer are the combination of hardware and software. So thank you. We will discuss in the next lecture. Thank you.